Adi? Adi?
Hey, hold on, let me kill that ogre over there. What's up, man?
Do you know anything about the VLE lab?
A bit, but not that much also.
Do you want to go to the office tomorrow and ask?
Yeah, yes, office hours tomorrow, so we can definitely do that.
Okay.
Alright.
Hi, Ken. Since you're a TA for VLE, can we ask some questions?
Oh, yeah, sure. Come on in. Take a seat.
Thanks.
We're doing VLE for this left cycle, but so far we know nothing about VLE.
Okay.
We know the basic concepts, but it would still be great if you could brush upon them once more.
Yes.
Okay. Well, to start, VLE stands for vapor-liquid equilibrium. This occurs in a closed system when there's no mass flow in and out of the system. In this system, we have both the vapor phase and the liquid phase. Mathematically, we can say that the vapor phase fugacity equals to the liquid phase fugacity. Can one of you guys go up and write the vapor phase fugacity expression for me, please?
So the vapor phase fugacity follows this formula. That's the vapor phase fugacity, which equals the mole fraction of the component in the gas phase times the total pressure to which the system is exposed to. And this equation is called the Lewis-Randall rule.
Good. Now can you go up and write the liquid phase fugacity expression?
Sure. Okay, the fugacity for the liquid phase is mole fraction in the liquid phase times is activity coefficient times is liquid pressure of the component. That's it.
Okay, so I'll sketch the TSY diagram. In this axis is temperature. This axis shows the mole fraction. So in the region above, we have vapor. In the region below, we have liquid. Between the two regions is VLE. To read the composition, say at this point, we draw a tie line and using Weber rule, we can obtain the respective compositions. In this point, we get the liquid mole fraction, and in this point, we get the vapor phase mole fraction. Notice that the liquid phase mole fraction is greater than the vapor phase mole fraction. However, after the azeotrope point, which is right here, and if we were to determine the composition at this point, you would see that the vapor phase mole fraction is actually greater than the liquid phase mole fraction. Okay, guys, that's why we need to know if the mixture has an azeotrope point or not. Now, does any one of you know where VLE is used in the industry?
In a distillation column, I know it's used to separate stuff.
Oh, good. So, any more questions?
No.
No.
Okay, well, we'll see you in lab tomorrow, pre-lab.
Yeah.
Yeah.
Thank you.
Okay,
Thank you.
no problem.
See you tomorrow.
Yep.
See you tomorrow.
Hey guys.
Hi, Ken.
What's the third member of the group?
You know it.
Well, let's just get started. First, I want to introduce the chemicals that you will be used for this experiment. There are acetone, ethyl acetate, and methanol. Since they're all highly flammable, they should be kept sealed at all times. Transportation of these chemicals should be operated under a fume hood, which I'll do ahead for you. During this lab, you'll be using syringes to transfer these chemicals into the ebullirometer. Here are the small syringes. You'll use the small syringe to transfer solutes into the ebullirometer. Notice that they are labeled. This is to prevent you from using the wrong chemicals. Now here are the large syringes. They are used to transfer solvents into the ebullirometer. While holding the large syringe, make sure to hold them up with the needle pointing away from your body. This is to prevent the chemical from leaking onto your hand. Okay guys, before you start the experiment, there's something that you have to do. Follow me. Okay, so before you start the experiment, fill this tank with ice. The ice will be used to cool the water in this reservoir. The water in this reservoir will be used for the circulation of the condenser, which is part of the ebullirometer system. Now follow me and I'll introduce you to the ebullirometer system. This is the ebullirometer system that you guys will be working with. Down here we have the boiler. The boiler is where the solution will be boiled. You can notice that there are many glass shards within the boiler. This is to help improve nucleation. When you start the experiment, it is recommended that you fill the solvent up until the black mark. After the solution boils, the two-phase flow will travel up into the Quattro pumps. The Quattro pump is where VLE will take place. The two-phase flow will then travel into the thermal well. Here in the thermal well, liquid phase will fall back into the boiler and the vapor phase will travel up into the condenser. The condenser will help circulate the vapor back into the boiler. Also note that inside the thermal well is where the RTD or the resistant temperature device will be located. The resistant temperature device measures the temperature of the VLE. The temperature measured by the resistant temperature device will be displayed in the LED up above. During the experiment, while recording the temperature, you should also record the time. You can also notice that the experiment is open to the atmosphere. This is to help keep the pressure constant. Okay, next we will go over safety for this experiment. Okay guys, so in the case of fire or vapor cloud, please follow ACES. ACES stands for Alert, Contain, Evacuate, and Special Assistance. So what this means is, if you see fire or vapor cloud release, please alert others, get out the room, and then shut the door to contain the fire. And then you evacuate to the steps of Pearson Hall, which is the rally point for this lab. So in the case of chemical spills, if it gets on your body, hold this to activate the shower. The shower will wash all the chemicals out of your body. If it gets into your eyes, push this to activate the eye wash. So if it gets into your eye, let it rinse for at least 15 minutes. And if the chemical gets on the floor, put a sheet of absorbing paper on the side of the spill, and then alert me or others of the spill. So, any other question for this pre-lab?
No.
Well, I'll just see you during lab then.
Thank you.
Okay. Have a nice day.
You too.
That's it.
Oh, come on, guys. It's already 12:30. Where are you? I'm not waiting. Get some ice first. Finally, someone's here. Where's Abby?
I don't know, like 10 minutes ago, I was playing more of Warcraft, and he was online playing with me.
Anyway, just help me get some
I'm
ice.
sorry.
More place. Do you know what to do?
No?
Okay, plug in the condenser first. I'm gonna put some ice in the vegetable.
What next?
Let's look at the chemicals. Okay, let's go. Put on your glove first, for safety.
Okay, I'm sorry.
Okay, now, we have to label them first, before we actually do any injections. Okay. It's already been labeled by PAs. Now, I'm gonna get the solvent. Be careful. Water. Let's wait
We need
first.
to record the weight.
Yeah, let's go get it. Record it. Now, we inject the solvent into the outlet. Haru,
Yes.
keep an eye on the bottom and tell me when to stop when the solvent reaches the right point. Okay? Checking out.
Keep going, keep going. A little bit more. Okay, stop.
Okay. All right. Now, start a boiler, set the temperature 4 degrees above the solvent boiler temperature. Okay?
Okay.
Now do it. Okay. We'll just wait for it to boil. Now let's go back and wait again. Okay. Now let's pull in the LED right in there and close it for a better heat isolation. So now we'll just wait for it to boil. Okay?
Okay.
This way. Now.
It's boiling! Come on, come on. See?
Okay, alright. No, go get your notebook and record the temperature. Go. Okay. Also, start a timer. Okay, awesome. So we'll do this every 2 minutes for 4 times. Okay?
Okay.
Okay, what's now?
I've just got the 5th data point. I think we got them all.
Okay, awesome. So now we're going to do our first solute injection, okay? Okay, now let's do the solute injection. First of all, I want to make sure the label is correct. Is correct. So I'm going to set the solute out. Okay. Now let's go and wait. let's do the injection. Okay, now, let's wait until it boils again. So we're gonna measure flash temperature each time, each injection. So we're gonna do totally 4 injections of solute, alright? Okay, now I'm gonna go back and wait this syringe again.
Okay, I've got the last data point.
Alright, awesome. So now we're gonna turn the system off. Firstly, we're gonna set the refrigeration option of the boiler to on and set the temperature to room temperature. So, and we'll just wait until it cools down, okay?
It's already room temperature.
Okay, good. Now you need to drain it, and you have to pour it in the waste container. And after you pour it into the waste container, please don't forget to record the volume that you poured in it, okay? Okay, now let's just clean the table and go home. Okay?
Yeah, the lab is over. Where's Eddie?
I have no idea.
Well, let's just go.
Hey guys, so when do we start with the experiment?
Oh, come on, really?
Ah,